This almost last lecture. There's one more, but it's really the major technical stuff is on confidence, and it sounds like belief type, but this is the frequency version of what belief type covers. So when you talk about confidence, you're really talking about what are called confidence intervals, and it's the basis. The best example is polling. Polling uses this. So it's stronger than significance, and that's why it's used more, but it also, unfortunately, can be abused and very often is. Two kinds of estimation. These are all in the quiz. A point estimate is basically a point. Think of it like a point when you graph it on a line. The points represent numbers, so 0 is 1 point. When you demarcate the 1 and the 2 and so forth, these are all points, right? An interval estimate, by contrast, is a range of numbers between 2 points, say between 90 and 100. And they're both estimates of unknown quantities of interest. That's what the key thing. You want to know some general quantity. You don't know it for sure, and you may never know that for sure. And so these are what these two kinds of estimation are about. So for example, if you want to know what percentage of the US population believes such and such, you can ask everyone, but that's way too much work. They never do that. So the kinds of estimates they're after are unknown quantities of interest. Remember, this is the frequency interpretation, so it talks about the overall population. Polls usually mix an estimate with an interval, a point estimate with an interval estimate. So the point estimate is 98% believe such and such, and then the interval is they give you the margin, what's called the margin of error. Here's something drawn from a paper, um, a politically charged topic, and it's guilty of all kinds of problems. So read it. It's clear enough. Just read it, take a glance at it. I'll cover it in the next slide. Take the third question from that poll, which indicates 58%, that's a point estimate, of Americans polled think that Islam has more violent extremists than other religions. That's itself a fallacy. What's being begged in that question? It's a complex question, actually, the way it's asked. We'll cover fallacies in the next lecture in some detail, not totally. Plus or minus 3 percentage points. So from 58, it's minus 3, so 55 to 61. They claim that this sampling poll is accurate to within 3 percentage points 95% of the time. Okay, so it sounds like you're saying 58% is a pretty accurate within some fudge factor, and that's sort of 95% accurate. But that's not actually what it says. Polls illustrate the sample to population. Basically, you're projecting from your sample to what you think is the population and your confidence in that estimation. How do they get that? Okay, recall the three facts. This is a lot of math here. Some of you follow, some not. I wouldn't worry about it too much, but I'm going to go through it anyway just to give you the theoretical background. It's building off of significance. Remember the three facts, right? 1 sigma is 68, 2 sigma is 95, 3 sigma is 99. Mu is the middle, is the average. So it's the middle of the bell curve, and then the sigmas are 1, 2, 3 sigmas are plus or minus from that middle, the mu. The worst case scenario is when probability p equals 1/2. This is just a mathematical fact. You can check it out. If you try p 1/4, it's not as bad. So the idea is that p, when it's 1/2, makes sigma the most spread out, no matter what n is, no matter the number of trials. Okay? Using the formula for sigma, that means 1 minus p times n equals 1/2. 1 minus 1/2 is 1/2. 1/2 times n. So 1/2 square root n. Okay? That's just math. This is the worst scenario. So it means all other fudge factors will be within that worst error bound. Okay, you take that, you transplant it into the three facts. So substituting in our worst case for sigma, the probability becomes at least 68 that S is within 1/2 square root of n. Why? Why least? Because if this is the worst case, all the other types of sigmas, as it were, calculations for sigmas, can only get better for other samples. Okay, you do some mathematical trickery. I mean, it's not even trickery, it's just basic math. You're just transforming the equation, right? And then you basically get this thing right here. You guys can do the math on your own if you're interested. Just trust me, it works. And then you get do likewise for the 2 sigma and the 3 sigma levels. So it looks like the 3 other facts. Remember, 1 sigma, sorry, 1 sigma corresponds to 68%, 2 sigma corresponds to 95, 3 sigma corresponds to 99. Now, since we've transformed the sigma with the worst case scenario, it then becomes this formulation. So 1 sigma becomes 1 divided by 2 square root of n. 2 sigma, if you multiply that by 2, the 2 cancels out, so it goes 1 divided by square root of n. And then if you multiply this by 3, it becomes 3 over 2 square root of n. So this is basically, this right here are the 3 key facts more or less you need for confidence. Okay, there's further transformations that go on. Again, I assume you read this. There's some logical tricks. When I do this lecture, people give me the sort of quizzical eye. Some get it, some don't. I've tried all kinds of things. Just read it. If it makes sense, great. If not, don't worry about it. Here's the bottom line. Again, confidence gives you, in a sense, since it's giving you the worst case scenarios, the converse of that is it's also giving you, in a sense, the best. I know that sounds weird, but here we go. There's at least a 68% probability of obtaining a sample that is within 1 over 2 square root n. These are your 3 facts, okay? So the 68 is 1 sigma, the 95 is 2 sigma, the 99 is 3 sigma. But since you're talking about the worst case scenarios when you transformed your p is 1/2, your probability is 1/2, you get at least 68 of within this, and at least 95 of within that, and at least 99 of within that. And you can just think, for your purposes, the essence is you will use these 3 formulas. So think, you just got to memorize the 3 formulas. 1 sigma is this, 2 sigma is that, 3 sigma is that. And what it's telling you is that this is actually giving you a better test of, it's a stronger version than significance. Because, ironically, strangely enough, we talked about the worst case scenario. So the worst case ends up being, in this case, a stronger version. I'll try to explain that briefly later when we get to how confidence pretty much relates to power, which we also glossed over in the last lecture. Here's the key conclusion form. Remember, the conclusion form for significance was, once you define your null hypothesis, either the null hypothesis is true and something unusual occurred at the whatever percent level, whatever your p level is specified, or it's false, right? Well, here's the version of that in terms of confidence. On the basis of our data, we estimate a quantity q lies within an interval I. In this case, your quantity q is like your percentage, 98% of your polls or whatever it might be, right? 98% of people believe blah, blah, blah. And then the interval I is with plus or minus so many percentage points. The estimate is made with a method that is right with probability frequency of at least 95%. So 95% doesn't relate, that's where confidence comes in. The 95% is not talking about how reliable your results are, nor does it reflect what's in the population itself. It's saying that this method, if you were to repeat it over and over and over again, 95 out of 100, or 900, basically whatever it might be, 95, let's say 95 or 100 times, that method would give you these reliable results. Remember, this is a frequency interpretation, so it's either a fact in the world or it's not. Either your actual estimation hits the mark or it doesn't. There's nothing else besides that. Okay, the quiz that's coming up, it's an important one because it's basically the type of things that you'll be asked on the final exam. The final exam has a range of problems. You have options. One of them is a problem with confidence involved, and you just basically got to know this type of thing. I'll talk about this later in the final review section in La Lima. But if you work exercises 1 and 2 on page 245, it's going to give you this same type of practice. I'm going to give you examples here, and we're going to cover that also in the quiz, but it's worth your time to work these exercises for practice as well as the quiz, because the final exam is pretty much exactly like these. Know the form of confidence statements. That's what the previous slide's about, the conclusion. And then this last one, what's the difference between confidence tests and significance tests? I'm just going to gloss over that really quickly on your own after, very quickly after this. You don't have to know this stuff in too much detail. If you read the book, good for you. But again, this stuff does not go down very well for most people, so I'm going to just basically hit the highlights. So let's use some examples first. So most polls, they sample 1,000 people or thereabouts. This is the way it's done. Okay, they don't first take a sample, fit the margin of error to that data. Rather, they first designate the margin of error they want. Usually it's going to be the 3%. It varies, but usually 3%. They then design their poll at a certain confidence level, say, in this case, 95%, right? So the Islam poll that we read above first designated the margin of error at 3%, and then sampled 1,000 people, and then got the results, and then plugged and chugged into those equations. Here's another example from the book indicating the same pattern. See page 237 in the book. It says there's a poll done indicating that 78% of city residents favor segregated areas for smoking, right? The poll sampled 1026, that's roughly 1,000, and is accurate to within 3 percentage points 19 times out of 20. Okay, well, how do you break this down? 19 out of 20, when you translate that 19 divided by 20, actually do the math. It equals, when you use a calculator, roughly 95%. So they're talking about the 95% confidence interval. To see where their 3% margin of error comes from, use the second fact. Because this is the 95%, that's the 2 sigma, use the second fact, which is this formulation, 1 divided by square root of n. Well, what's the n they use here? 1026. So what is that? Again, you're not going to have calculators for the final exam. So how do you do that? Well, square root is what times what equals that. So what's 30 times 30? That's 900. What's 40 times 40? Well, 4 times 4 is 16, so it's 1600. So 1026 is somewhere between 30 and 40. So you can do a rough estimate. Let's say 33, right? 33, 1 over 33, when you divide that, is going to be roughly plus or minus 3%. So that's why they have 1,000 people. And then that then gives you your 3%. So the confidence interval is going to be the percentage they got, 78%, plus or minus 3 percentage points. Note that as confidence increases, so does your fudge, since you're more confident that your results will fall within those wider margins of error. So the problem here is that if you sample more people, what happens? Well, intuitively, if this number gets bigger, your denominator, the thing on the bottom that you're dividing by, also gets bigger. So intuitively, your plus or minus gets smaller. If you take a smaller poll, let's say only 100 people, right? Then square root of 100 will be 10. 1 over 10 is not is a fatter confidence error fudge range, right? So if you take a smaller poll, you get more fudge. Your confidence, ironically, means you're more confident it falls within that, but you should think, if anything, your results aren't as good because you didn't take a big enough poll. If you take a bigger poll, the idea is your interval gets more narrow, more narrowly constrained. So in fact, the irony is your confidence, as it were, goes down. But that's because your fudge goes down. That's because what you're estimating gets slightly better. Confidence intervals are pretty much the same as power. You can read this through. Again, if it makes sense, great. Don't worry about it. Here's the bottom line. Take-home lesson. Confidence intervals and power are pretty much the same. And here's the point. They're both stronger than significance tests since they include considerations of type 2 errors. The way confidence does that has to do with basically the way in which it takes into account the worst case scenarios. Yeah. This is tricky stuff. Again, don't worry about it too much, but this is what you need for the quiz. So confidence intervals are stronger than significance, and all you have to know is they take into consideration type 2 errors. That's just the jargon you need. Okay, that's it for this lecture. The practice is going to be crucial because if this stuff is still unclear to you, it's really just the application of the 3 facts and the formula and the formulas you need. These formulas right here: 1 divided by 2 square root of n, 1 divided by square root of n, 3 divided by square root of n. All you really need actually is to memorize this first one and to remember that 2 sigma is just multiplied by that by 2 to get that, and multiply this by 3 to get that. That's really all you need. So just to remember 1 over 2 square root n to get the other 2 formulas, and that's what you need for confidence.